Okay, so just kind of reviewing what we did yesterday, we talked about function notation. Okay, so if we were going to write out the function notation for these, it's just talking about function g. So function g is this guy over here, and function h is this guy over here. Okay, so if I were to say distance from point 60 seconds after the owner left, what's the shorthand version of that? Like, what would we write as mathematician? We would say g of what? 60. Okay, it's not a trick question. It's that easy, right? Now, if we were talking about function h and we wanted to look at 60 seconds, what are we going to put inside here? 60. The next one says distance from post when the owner left. When did the owner leave? 0 seconds. So we're going to say g of 0 and h of 0. And the last one, g of 150, h of 150. Okay. Now, if you actually found what the y value was, great, but that's not what it asked you to do. It just said to write it in function notation. Okay. Questions about that? Okay, fantastic. All right, so now we're going to describe this. So this is going to be h of 20. This means that we have distance from post at what time? 20 seconds after the owner left. On the next one, exact same thing. We're just changing that 20 to be 80. And then part C just tries to trip us up, but all we're going to do is replace that 80 with a T. We're going to say distance from post T seconds after owner left. Okay, what you're going to see most often is this one. This is talking about this scenario in generality. Okay, it's just kind of telling us what's going on in the scenario with shorthand. Any questions over that? Okay. All right, number 3. We've got at 10 seconds, the dog was 3 feet from the post. Okay, so the seconds were what's in here, and the distance is the thing that's out here. The next one, we're going to do the exact same thing. So at 110 seconds, the dog was 1 foot from post. And the last one, again, they're just trying to trip us up with a bunch of letters. We're going to say at t second, the dog was d feet from post. To go over this. These little signs right here, what are they called? Do we remember? They're not equal signs. They're inequalities. Okay? So inequalities, this is what we learned back in, I think I learned it in 6th or 7th. Actually, before that. It was like 4th and 5th grade. So inequalities are these little symbols. Your teacher probably said like alligator mouths. And then your teacher probably was like, hey, the alligator eats the bigger number. Yeah, does that sound familiar? So like if I had 5, 3, which one's bigger, 5 or 3? 5. That's why the alligator mouth is facing this way. Does that make sense? So the way we read this is we say 5 is greater than 3. Now, if it was the other way around, so let's say we had 2 and 3, which one's bigger? 3. That's why the alligator mouth is facing that way. We would say 2 is less than 3. Everybody understand those symbols? Okay. All right, good. But over here, we've got g of 80. If we go back to our graph, I'm going to erase all of that junk. if we go back to our graph and we look at where V is, and when X is 80, what's our Y value? 2.5, okay? Now, if we look at when H is 80, what's our Y value? 2. So which one's bigger, 2.5 or 2? 2.5. So the alligator mouth has to be facing towards the G of 80. Is that what's happening here? Yeah, so that's going to be a true statement. So we're going to say true. Can you try B? Okay. Okay. So what is H of 60? What number was that? 4. And G of 60, what number was that? 4. So is 4 bigger than 4? No, so that's false. Everybody see how I got that? Okay, cool. Flip over to the back. Okay, so reading this little scenario up at the top, as the function W gives the temperature in degrees Fahrenheit of a pot of water on a stove, minutes after the stove is turned on. I want you to take turns. You're going to just work with a partner, and you're going to explain the meaning of each statement in this situation. When it's your partner's turn, listen carefully to their interpretation. If you disagree, discuss your thinking to work on an agreement, okay? We're going to take about 5 minutes to kind of discuss this. I want you to use the words like in terms of context. So don't just say W of 5 is greater than W of 2. What does that actually mean in this scenario? Okay, so I'm gonna give you about 5-ish minutes to kind of work with a partner, and then we're gonna kind of collaborate on that. Take turns. So somebody go first, describe what this means, and then go to the next one. Okay. So just a reminder, we're talking about the degrees in Fahrenheit of a pot of water on the stove after a certain amount of minutes, right? So what does this first one represent? What does W of 0 equals 72 mean? Perfect. So, I don't know if y'all have ever like cooked like mac and cheese or whatever, but like if you actually just like put a pot of water on the stove, it's roughly about 70 to 80 degrees. Like that's automatically what happens. And that's at 0 minutes. That's you putting it on the stove. Okay, good. All right, what about B? What is this? It's true? Okay, but what about it? Like, interpret what it means. Say that again, sorry. Boom, okay, cool, good. So 5 minutes after stove was turned on, it was greater than 2 minutes on. Okay, and you could have worded that a little differently, but as long as you were talking about the 5 minutes being greater than the 2 minutes, then you're good. Okay, fantastic. All right, I'm gonna skip that one. Let's go to D. What does this one mean? W of 12 equals W of 10. Good. And like, let's think about that. If you turn on the stove to like a certain level, it's only supposed to get that hot, right? Yeah, supposedly. Hopefully don't have like a messed up stove. But like when you turn it on, it's supposed to get to that temperature. So after like a couple of minutes, it should stay at that temperature. Okay. Do we need to go over any more? We good? Okay. Perfect. Loving it. Okay, so if all the statements in the previous question represent the situation, sketch a possible graph of the function. So be prepared to show where each statement can be seen on your graph. Okay, so what I want you to do, this one's a little tricky, but remember how this is our X, what's inside the parentheses, and then this is our Y, right? So you would plot a point at 0, 72. Do we know how to plot a point? Yeah. Okay, so go ahead and put that one on your graph down at the bottom. For part C, we've also got 10, 212. Okay, and then we'll talk about the other ones in just a second, but go ahead and plot those 2 points. All right, so then we have these other things that they tell us up at the top. Okay, so we had on part B, it said 5 minutes was greater than 2 minutes, right? Okay, and then on part B, 10 minutes was equal to 12 minutes. Okay, and then 15 was greater than 30. What happened at 15 minutes and 30 minutes? What happened? Do you leave your stove on for like forever? No, we probably turned it off, right? Okay, cool. All right, so looking down here, when we sketch a graph, and this is just a potential graph, we know that it's going to increase sometime from here to here. And then we said at 10 and 12 minutes, it's roughly the same, right? Does anybody know what the temperature of boiling water is? Does anybody remember that? It's been a minute since I've looked that up. Boiling water temp. 212. And what's our whole goal? We want water to boil, right? So it's going to get to 212, and then what is it going to do? Stay at 212, right? Okay, so looking at our graph, we're going to chill at 212 for a minute. And then it's probably going to go back down because we're going to turn it off, right? That makes sense? And again, the graph could be a little different, but it's going to look like that shape. Okay, cool. Questions on that? So we're going to talk about patterns. So choose one pattern below. This is not on your paper, so look up at the screen. Choose one pattern below. How do you see the function growing? So like either pick function 1 or function 2. How do you see this growing? What's going on? So what's happening in function 1? How many blocks do we have here? We got 4 blocks. Okay, figure 2, how many blocks do we got here? 1, 2, 3, 4, 5, 6, 7, right? That's okay. It's hard to see on the screen, so I get it. All right, on the next one, how many we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How much are we going up by each time? 3. Do we see where that's happening? So look at it this way. This is the original shape. 1, 2, 3. So what's happening? We're adding 1 on this side and then adding 2 over here. Do we see it? Okay, look at the next shape. From here to here, how many boxes do we have here? 5. And then how many boxes do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9. Good. And then how many do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Again, it's hard to see on there. All right, so what's happening on this one? Is this adding up each time consistently? No. Okay, so let's look at the shape. We got 1, 2, 3. Here's the original. 1, 2, 3, 4 here. So what did we do? We added 2 here. We added 1 right here. We added 1 right here. Here's the original from the second figure. Gosh. Nope, JK. Go back. So this is the original figure from figure 2 to figure 3. So we see how we're adding on more, right? But this is not linear. We're not adding a consistent number. Like here, we were adding 3 each time, right? So this one's going to be a little different, which we're going to talk about that in just a second, okay? All right, so we're going to continue the study of the characteristics of functions using patterns. Okay. So on your paper, I think you've got these three images. Okay. I want you to try to figure out, what are they growing by? Like, what's happening? How are they increasing? So take a moment, kind of count up the tiles, kind of tell me a pattern that's going on. Take a second, just kind of look those over. So let's kind of chat through this one. All right. Function B. So that's his first one. Looking at the white tiles, or the tiles that are in the middle, how many do we have in the first one? One. How many do we have in the second one? And then how many you had in the third one? Okay, so what are we going up by each time? So we're adding one each time. So we're adding one each time. All right, the next one's a little tricky to see. We've got how many in the first one? One. How many in the second one? How about in the third one? So what are we going up by? Are we adding three each time? No. Okay. What if we look at it this way? This is a square, right? And what's the definition of a square? Yes, but what is a square compared to a rectangle? How are they different? 4 equal sides. Okay, so we got an equal side, right? How many units do we have here? How many boxes make up a side? 2 and 2, right? And then over here we got 3 and 3. This is going to be that we squared it. Yeah, do we remember what squaring does? It takes the sides and multiplies it by itself. So what's 3 times 3? That's how we got this many boxes. Okay. So if it makes a perfect square, it's probably going to be that x squared. All right, function G is a little tricky to see as well. We started off with 2, right? And then we went to 4. And then we went to 8. So what are we doing each time? Multiplying by 2. Let me see where I got that.
I don't know if you're supposed to look at the white box for the like the color.
So you could have looked at the blue, like the whole thing. That's fine, because what you're gonna notice here is how many boxes do we have in total in this figure? 1, 2, 3, 4, 5, 6, 7, 8, 9, right? 9. And then how many do we have in figure 2? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? And then how many do we have in figure 3? 15. What are we going up by each time? We're going up by 3, right? But still the same process of just adding, right? Same thing with the next one. How many boxes do we have in total? We had 9. How many boxes do we have here? We got 16. How many boxes do we have here? 25. Okay. So again, same process, just smaller to look at. So normally you would look at the entire picture, but they wanted us to just look at the unshaded region. Okay. So what did we find? And this is on your paper, right? Yeah. Okay, so B of X. So in the first figure, how many boxes did we have in total? We had 9 in total. What about on the second figure? And then third figure? What about the fourth figure? I know there's not a picture there, but what would it look like? Why'd you say 18? Exactly. So then 18 plus 3 would be? Okay, good. Okay, this is going to be represented by a linear function. Okay, going to be a line. Oop, I take it back. It's okay. So let's say that we went back a number. Let's say that we went to figure 0. What would that be? Like if we have 9 in figure 1, what would be 1 behind it? 6, right? Okay, so at 0, we're going to have 6. What about 1 behind that? What if we went 1 backwards? Be 3. And then 1 behind that, what would that be? So we would have a straight line, right? Now I do want to make a note. If we were just talking about the white boxes, this is what it would look like. It would be 1, 2, 3, right? And we would have 1, 2, 3. It would go up like this. I want you to draw both of these lines. Is that what you were going to say?
No, doesn't everyone have 8 boxes in the
1, 2, 3, 4, 5, 6, 7, 8, 9. If you include the white box. Yeah. So all the boxes in total, then it would be 9. Okay. So the red one is looking only at the white boxes. And this black one is looking at the entire figure. I want you to graph both of them though. Okay, so we got linear, we got quadratic. JK? Nope. Okay, so on this next one, how many white boxes are in figure 1? How many are in figure 2? Figure 3? 8. Okay, what about figure 4? What about figure 4? Why do we have 16? You're multiplying by 2. Okay, so what's 16 times 2? 32. Okay, this is called an exponential function. I don't think y'all have seen this, or if you have seen it, you might have seen it last year. Okay, and that's going to be represented by y equals some base raised to the x. I want you to write this down. The reason why we're writing b here is because that number changes. Do you see how this word right here says exponent? And notice how x is in the exponent. That's how we identify if it's an exponential. So if the x is in the exponent, it's an exponential. And the number down here, this little base, can change. Now, I don't expect you to write all of this down at all, but these are the different types of parent functions that we're going to talk about. Okay, so we just went through these 3. So we got linear, we got quadratic, and we got exponential. Now we're still going to learn about square root and cube root. And then we're going to briefly talk about absolute value. Okay, so those are the 6 parent functions that we talk about. Again, I don't expect you to have those memorized. Okay, go ahead and move on to this page right here. Okay, it says a toy rocket and a drone were launched at the same time. In the past, I've seen a lot of people are struggling with key features. Okay, so I want to practice those as much as we possibly can, because key features are going to be important. If you don't understand what's going on in the scenario, then you can't really do much with it. So we got a toy rocket, we got a drone, and they were launched at the same time. Here are the graphs that represent the heights of the 2 objects as a function of time since they were launched. Height is measured in meters above the ground, and time is measured in seconds since launch. Let the function r represent the toy rocket, and let function d represent the drone. Okay, so looking at this, which one's which? R is our rocket, G is drone, right? Okay. What is an x-intercept? The x value when it touches the x-axis. So where's the x-axis? Well, down here. So our x-axis is right here. Okay, so we're looking at the x-intercept. Now there can be more than one. Okay. Now let's think about this in real life terms. Where is the x-axis in our real world? The ground, right? Okay, so meaning in words, the x-intercept is where it touches the ground, or you can also say this as the x-axis. Now, when we launch a rocket, normally we launch it from like, a cliff or higher up, right? So it can get more height. Where did this rocket touch the ground? Where did it touch the x-axis? At 5. So we're going to call this 5, 0. After 5 seconds, the rocket touched the ground, right? Okay, what about the drone? Have you ever flown a drone before? But like y'all seen a drone before, right? So they always start on the ground, right? Then they go up, they move laterally, and then they go back down, right? Okay, so where did it start? So we have 0, 0 is an x-intercept. And then where did it stop? Okay, so we got 7, 0. Remember, when we write points, we always write our x, then our y. So whatever the left-right number is, and then the up-down number is. So that's why it's 7, 0 or 0, 0. Be okay on that. Okay, what's a y-intercept? It's a y-intercept. So if an x-intercept crosses the x-axis, a y-intercept is going to cross the y-axis. Okay, so, all right, so y-intercept is going to be the height of the object starting. Okay, it's also going to cross the y-axis. So again, talking about that rocket, we always want to have it like on a cliff, right? So we've got this right here starting. How high is that? So what's the number that's right in the middle in between 20 and 30? 25. Okay, so we're going to have 0, 25. And where did the drone start? At 0, 0. It started on the ground, right? Okay, the domain is going to be all x values. All your x values that is in the situation. So this is talking about the time of flight for either the drone or the rocket. So this is talking about the number of seconds it's in the air. So when we look at this, how long is the rocket in the air for? For 5 seconds. It's from 0 to 5, right? Okay, so when we come down here, we're going to write from 0 to 5. Notice how I use those little brackets? Because they include the rocket doing something. To put this in like real life terms, the rocket was in the air for 5 seconds. Now, what about the drone? How long was it in the air? 7. So from 0 to 7, right? So the drone was in the air for 7 seconds. Domain does not go away. It always is asked. For range, if we're dealing with X values for our domain, what do you think we're dealing with for our range? All the Y values. Okay. Now, what are we talking about in actual context terms? Well, this is talking about the height of the rocket or height of the drone. So we're looking at the lowest point that it's in the air and to the highest point that it's in the air. Okay, so looking at our graph, how low does the rocket hit? Does it touch the ground? Yeah, so that's 0. How high does the rocket get? 45, right? So we're going to say from 0 to 45. What about for the drone? What's the lowest that it gets? And what's the highest that it gets? Okay, so from 0 to 20. Are there any questions about intervals of increase and decrease? So, have you ever been to Six Flags? Have you ever rode Goliath? Some people are like, yes, but no, but yes. It's okay, me too. So on Goliath, y'all remember like the big drop? Yeah. So increasing, you kind of want to think of it as riding a roller coaster. So imagine you're on a roller coaster. You're chilling over here. This is you. Okay. You get in the roller coaster. This is the part where you're like, man, I wish I wasn't getting on this roller coaster. Like, please let me off, right? That's when you're increasing. Your heart rate increases. Your height is also increasing. Okay. This is where you regret all of your life decisions. This is where you're decreasing in life, right? Yes. Okay. So increasing is going up. Decreasing is going down. Okay. Now, what we want to do is we want to look at where and when does that happen? So when do we start increasing? At 0. We want to look at when that happened. So that's the time, right? So we're increasing from 0. So when do we stop increasing? When do we start going down? At 2. When do we start decreasing? At 2. So when do we stop it decreasing? Look at the time. Look at the X values. 5. 2 to 5. Go back. 2 to 5. Does everybody see where I got that from? Okay, so coming down here and filling in your chart, what you're going to put is you're going to say intervals of increase. When the height is increasing, what is the time? And we said for increase, it's going from 0 to 2. And then for interval decrease, this is when the height is going down. What is the time? And we said from 2 to 5. Let's look at intervals of increase or decrease. So again, we're in our little cart, getting on the ride. To go up or down? Up. So we're increasing first. Well, how far does it increase? We go from 0 to 2. Okay. So from 0 to 2. Now, we get up here. Do we increase or decrease? We don't. But we don't include this in anything, right? When do we start decreasing? At 5. And when do we stop? Okay, so 5 to 7. Let's go down. And then if you have any questions, just we can talk about them. So the first one should have been true. The next one should have been true. The next one should have been false. Next one should have been false. Any question about those 4? We okay on that? Okay. Again, I'm not interested in the like answer. I'm interested in, did you understand why? Okay. All right, the last 2 should have been false and then true. Any questions about that? Did everybody understand this notation right here? No? Okay, so this is the same thing as saying 0 to 50. Those are the same things. So you have whatever values in between, that's your y values. And we're saying this is the lowest, and this is the highest. That's all that's saying. Okay. Is there another one that was tricky? Same thing with this one. It's talking about the x values. This is your left to your right. Okay. All right, go ahead and flip over to the back. I want you to get a little bit more practice with this because this stuff doesn't go away. And if you don't know these like 5 things, then it's a problem. Okay, so go ahead and flip over to the back. I do want to remind you of a couple of things. If you were not here yesterday, okay, you need to go back and go to yesterday's stuff. And I need you to make sure that you have this completed. So this About Me PowerPoint, I don't think we had enough time to completely finish it in class. But what you're going to do, maybe I didn't give you that much time. Okay, so on this one, this is that first period About Me, okay? This is going to be due by Monday. You're going to pick a slide and you're going to fill in your name and just answer the questions. And the questions are really simple. And then you can just decorate the slide. This is due Monday. Okay, cool. So if you weren't here yesterday or you didn't start on it yet, you need to make sure that you work on that. So 2 things I need you to make sure that you get done. One is this PowerPoint, 1 slide, just put your name. Please make sure that school appropriate stuff. Okay. And then the other thing is what you're working on right now, the back page. Okay, so that's what you're working on right now. Okay. Any questions? So finish this page, get that PowerPoint slide done so you don't have any homework this weekend.